Alright, so we're going to be on lesson 1.3. How many pets do you have? We're going to do a couple lessons today, and then I'm going to see y'all tomorrow. Tomorrow we're going to talk about, actually today the AP College Board is starting to release daily videos for every AP content. So like statistics, it's like, they said it's going to be like 5 to 10 minute video going through the sequence. So they might be behind us, I'm not sure, but they might be with us. I don't know where they're going to be at to start, but those would be really good, you know, extra help, or like if you didn't understand something, or like review the night before, you can watch all the videos that they've posted on our unit that we've done, because the teachers that they have on there are really good. So we're going to look at those. We're going to look at one of those tomorrow. I think they're posting it today. And maybe I'll show you how to get on to the, I tried posting that link in 2 different emails through Hack, and it didn't want the attachment that I had. So I'll show y'all how to get on the College Board for my site, which we're not going to worry about until Friday anyway. And then maybe if we still have time, because it's only an hour class tomorrow, we will look at like a free response problem rubric, and y'all can kind of get a feel of like what those look like. So yeah, that'll be tomorrow, and then we got a quiz on Friday with some homework due. So there's 1.2, 1.3, and the multiple choice homework due on Friday. So kind of at the end of a unit, it piles up, and then a test on Tuesday, which is like 10 multiple choice and 3 free response off the top of my head, something like that. Okay. Sweet. So we are doing quantitative data, so kind of like on whatever day that was. What day is today? Tuesday. So last Friday, we talked about some graphs for quantitative data, and we're going to go into solving for a few more things, and box plots, and still be using SOCs or SOCV, whichever one. Okay, so we need some class data here. And I don't want to get too many points because we're going to do stuff by hand. So let's get like 7 or 8 people here. Like, how many pets do you have? So, someone
4.
want to say
4.
4? Okay. Oh, no. Is it going to write? Ah, it did. Good job, board. Okay. That's 1.
3.
3.
3.
Got 1. And then 3. Okay.
4.
Huh?
4.
4. Okay, I'll put mine in for 0.
Aw.
6. Okay. Someone else? Maybe 2 more people, or at least 1.
3.
It can be a 0. 3. Okay. All right. Maybe we'll stop there. That'd be good. What was that? 7. Okay. So here's our class data set, and what I did was took a sample of second period statistics. The individuals were students, the variables were how many pets do you have, the variables are quantitative because it's numerical data, and yeah, I'm trying to think what else. So we're going from there. We can get some basic numbers here. So calculate the mean and median for the data set and compare them. So since we're so small in numbers, we could add these up and divide by the number. So add up all your numbers. So do 4 plus 3 plus 1 plus 3 plus 4 plus 0 plus 3 divided by 7 for the mean. What's that? 8, 12.
Oh, it's over here.
16 divided by 7, yeah, it's an ugly number. 2 point something? Is that right? What's the exact number? I don't know.
I'll just calculate.
I don't have my calculator. Maybe I should
What
have
is
it.
it? 18 divided by 7?
Or is it 18?
18.
Ah, 18.
Divided by 7.
Sorry.
2.5. 2.57.
It's still 2 point something, isn't it?
Yeah, 2.57.
Okay, sweet. 2.5. Okay, if we're gonna do, is it like rounded up to 7 or is it actually? the-
It's 7.1.
Okay, perfect. Yeah, just want to make sure we're rounding correctly. Okay, so yeah, that's the mean, the average. Another way you can see it and get used to it is, well, actually that would be listed as X bar because that was our sample mean. So maybe I should be good about that. So if you ever see like an X with a bar over the top of it, it's called X bar. That is your sample mean, sample average. Yeah, I won't get into the other one. Let's do our median. Let's see. So we got 2, and it looks like it is 3. Nice. Alright, so this is part, basically on the SOC-V thing, we're going to talk about outliers, center, and spread today. We're going to do all the different types of outliers, centers, and spread that we could calculate. What's the range of our data?
Oh, that's
4.
Yeah, 4 minus 0 is 4. Alright. So getting some nice stuff here. So I got our median, got our mean, our range. So I can use one versus the other. I'm not sure, I'm trying to check if I asked for it later. I don't think I did on this one. Let's just do this real quick since we talked about it last video. So let's see, 0, 1, 2, 3, 4. So I had a 0, a 1, 1, 2, 3, and 1, 2. So what would the shape of our dot plot? Roughly, we have really small data points, but this is all we have to go off right now. What would our shape be? Yeah, skewed left. Like if I looked at the top of it, I am skewed left. The tail is to the left. I ski down the mountain left. And so if it's skewed data, would I use the mean or median? Y'all remember that? Yeah, the median is more likely to tell me the more accurate center of where my data is at on skewed stuff because that mean is getting pulled by that 0 and 1. But most of our average, whatever, is near that 3. So just kind of a note, a reminder, since I pulled that into that last lesson. So we'd use the median on this one. So another thing that when I have skewed data like this, so I'm glad we had skewed, the range is not really a good measure for spread on range because on skewed data, because like if I had some sort of big outlier, that range is going to be massive and it might not really represent the true spread. So what we're going to use most of the time on that is what we're going to use on skewed data is standard deviation. So y'all might have had some experience with standard deviation. Maybe you've calculated it, but yeah, so that's going to be our nice measure. So what standard deviation is, here's our nice basic definition. Standard deviation is the average distance that our values are from the mean. So I go from the mean and I want to get on average how far do my values vary from that. So that kind of gives me a better measure of like, okay, here's my center, and are my values really spread out from it, or are they not? So if I just did like a quick problem here. Let's see, okay. Okay, so this is like A, B, and C. A, B, or C, which one has the smallest standard deviation? A.
Is it
It's right at next.
Yeah, like I would say the average on all of these, I tried to make it right in the middle. Like the average would roughly be that tick mark. So A has probably the smallest spread overall from there. So A is the smallest. B is probably the biggest, right? Because B, to get to them, the average distance, I have to go way farther away than the others, and then C would be the medium one. So this would be like largest, this would be smallest. So average distance. Alright, so let me get our values. So I'm trying to remember, it was like a 4, 3,
1, 3,
One.
4, 0, 3.
okay. Alright, so there's my values. This is one of those days that for the most part I'm just gonna we're gonna interact together but not like total y'all go. We could, but also I'm just afraid of running out of time sometimes. Alright, so the distance from the mean. We're trying to get our average distance from the mean, so I need to calculate the distance from the mean on every single one of these. So getting distance from the mean is a subtraction problem. So I'm gonna do like my number minus the mean. So if I wrote that in a math formula, it would be like x would be my number, whatever it was, minus x bar. There. How about, was it 2.57?
Yeah.
Can we use, are you okay with 2.6 instead? Just so that we don't go, I don't know. Just so that it's a little bit nicer on our calculations here. We could have done it the other way, but, and if you've already done it, it's fine. So 1.4, how about I'll just go through all of these, this whole little column here. So I'm gonna do 3 minus 2.6. So,
4.
yeah, 0.4, 1 minus 2.6, yeah, negative 1.6, 3 minus 2.6 again, 0.4, 4 minus 2.6 is again 1.4, 0 minus 2.6, negative 2.6, and 3 minus 2.6 is again 0.4. Okay. So every single, I want to do a small data set here so that we didn't have to do by hand for all of them. But here's our distance from the mean for every single value. 1.4, 0.4, negative 1.6, 0.4, 1.4, all the way down. And so they have a next column in the formula. They want us to take that number, x minus x bar, and square. Why do you think we're squaring? Like all I want is the average distance. So why am I going through the process of squaring my data?
Because it's on both sides.
What do you mean both sides?
Like say where the median is on the line. So
Uh-huh.
you have to go on both sides of the line to see the distance. What line?
Okay. Yeah. So like I'm trying to get them to be positive,
Yeah,
right?
yeah,
Like their
yeah.
distance is
Positive.
going that way or that way. So how about I just make sure to get them positive so I can plug in this formula for anything. So like on this case, if I was doing every single one of these problems by hand, then sure, I could probably just make these, like change the negatives into positives because it's distance. But if I'm plugging into some general formula for me using like a poll of the US where I took 1,000 people, like I need some sort of general formula. So that's why we're squaring it, because that's gonna make all of our data positive no matter what. So I'm gonna square every single one of these, and I don't know any of these squares off the top of my head, so I'm gonna need your help. We only have like, what is that, like 4 numbers. So could y'all do like 1.4 squared?
1.96.
Okay. And then 0.4 squared, that'd be like, is that 0.16?
Mhm.
And then 1.6
2.6.
would be 2.6? Okay. Then that's another 0.16, that is another 1.96, And then down there, 0.16, what's 2.6 squared?
6.76.
0.72?
6.
676, okay. Alright. Sweet. So I squared it so that I could get all my values positive, because direction is always, distance, not direction, distance is always some sort of positive length. Even if you're going backwards, you're going some sort of positive direction away from where you went. So then I'm going to add up all of those together, and I'm going to get my total, which maybe I'll take a volunteer for that as well, since y'all are already doing such a lovely job. So can someone add up all of those lovely terms together and get our total?
13.76.
Okay, sounds reasonable. Anyone else who's doing it, can just confirm unless you get something different? Okay, so 13.76. So now I'm trying, so that was my distance positive for every number. Now I'm trying to get my average of them all, because we're doing an average. So a mean, an average, is I have to add up all my values. So there they are, 13, and then divide by however many I had. So we're doing like an average problem. I'm doing a mean. So we did all my values divided by 7. Which is almost 2 something, looks like.
1.97.
Alright. Seems very believable. Okay, so 1.9, 1.97. So I'm trying to get, our focus here is to get the average distance of all the values from the mean. So I got my distance of my values from the mean, but then I wanted them to be positive, so I squared it. And then I want the average of it, so I add them all up, divide by the total. There's my number. One last thing that we have to do is this number is still all of our values squared. So one last thing that we need to do is to get back was I need to take that 1.97 and square root it. So I squared it to get it positive, and then I want it to get back into my same units of whatever they were. So we square root 1.97,
1.4.
1.4. Okay. Alright. And 1.4 would be our standard deviation. So maybe I'll shorthand standard deviation. Another way you could see it written, this was a sample standard deviation, so it might be written like this, S of X. So that would be like the notation. Don't have to worry too much about the notation, but I'll throw it in there so that y'all can feel good about it when we see it, when we have to use it more later on. So S of X. So let me interpret this before we move on to the next thing. So I went through my process. I'm 1.4. So what does 1.4 mean? Like, what would the interpretation of 1.4 standard deviation mean for our classroom set of pets that we have?
Is it like the average distance from the mean?
Yeah, so if I put it in context with my problem, so that's good. I like it's 1.4 is our average distance from the mean. So maybe I'll give it a crack here. So it would be on average we are 1.4 pets from the average of, what was it, like 2 point something? What was our average? 2.6? Okay, so on average we vary 1.4 pets from the average class set of 2.6. So that's on average. We're gathering most of our people inside of that standard deviation. So that would kind of be that interpretation. Okay, let me also do our formula that we did. So we did x minus, so we did our value minus the mean. That was the first step we did. And then we wanted to get them positive, so we had to square it. And then we wanted to add up all of those values, which is the nice symbol sigma. Just means add up all of those terms. And then we divided by the total. And then I had to get that number and I had to get it back to my original. Since I squared it, I had to get it back to like where it was, so I had to square root that number back.
So is that like the formula?
That's like roughly our formula. There's going to be one minor change. I'm going to show you the formula in a second. So that's what we did. When you look at that, if I was just giving you that in a PowerPoint and then I say let's do some problems on it, it might not have seemed as basic as what we just did. It's pretty simple. Take your numbers, subtract them all, square it, add them up, divide by n. So understanding the little symbols between there. Let me use Staplet real quick. There's a way to get your numbers on your calculator, but since we're going to be using our computers for the most part, Staplet is like a pretty easy interface to do stuff on. So I'm going to do that real quick. Unless the Wi-Fi, doesn't work. Yeah, Oh, there we go. Okay. One quantitative, so let's see if I can remember by heart. We were like 1, 3, 4, 3, 4, 0, 3, something like that.
Yep.
Okay. Oh no, that should have gone down there. Copy paste. Okay. Pets. Begin analysis. There's my dot plot. Roughly what I drew, except they did a little bit more spread. And okay, there's our mean, which we did get 2.571 as our mean. But their standard deviation was, we got 1.6, right?
Because we rounded that number.
Oh, we got 1.4. Okay. So it could be from rounding, but also it's also something slightly different in our formula. So I have standard deviation 1.5. The formula, let's see, there it is. So the formula sheet, if I zoom in to the side here, was almost exactly what we put, but they throw in a sample size -1. And if I write myself a note remembering why they do sample size -1, I can't really, they do that on degrees of freedom. I think it's so that like they give room for a little bit of variance with like your sample size being large enough. I don't know. I can't remember off the top of my head why they do n-1, but they do. So that's why ours is slightly different than theirs. And because we rounded, they probably didn't round at all. So they got 1.5. We got that number, whatever it was, 1.4. Basically the same, but technically, so let's see, what was it, like 1.57? So theirs was accounted for by the formula being n-1, not n. It's not a big deal. The reason I'm not worried about the n-1 is that it's not a big deal that you know why it's n-1. I've never concentrated or seen that on a problem. So that's our formula, just so that you feel confident on it. Basically, us doing it by hand was all the same except that n-1. So just feeling good about using our symbols and addressing that. Okay, we forgot that I'm a crazy person and that I have 30 pets, not 0. I put in 0, I forgot. I actually have 30. Okay, so what does that do to our mean, median? So mean, our median, our standard deviation. Well, we can even do range. let's do that. So Staplet's nice and easy because I can just come up here and change 30 or round it up to 30. Are you sure? I am sure that I want to do this. Okay, there I am. My daughter just loves chickens and dogs and and we have cows. There we go. That's what it was. We have 30 cows. That's right. I forgot about my cows. Okay. So what did we get for our new stuff? So we got a mean of 6. Y'all write these down so that I don't have to remember them. Standard deviation 9.7. We'll just say 9.8 will be fine. On the rounding side of it, it's not really until probability where it's okay for you to round off to like 1 decimal if you want. Okay, so let me write these down. So I remember we had a mean of 6, right? What was our median? 3. Our standard deviation was like
9.8.
9.8. Did I say 6? Go to 6. Wow. Okay, and our range 30. 30 minus 0, 30. Okay. So how does it compare to the original stuff? So let's just say let's go for our differences here. So we had, was this we ended up going with 2.6, 3, what did we get there? Technically it should have been 1.57, and then we had a range of 4. Okay, this is like our original column there. What are the ones that really changed? What are the ones that really got messed up? Okay, yeah, definitely range. Standard deviation got spread out too. And even the mean, right?
Yeah.
So what that means is something that we get tested on are something called resistant measures and non-resistant measures of spread. So resistant measures and non-resistant. So if I am a resistant measure of center or spread, then I don't change much or at all sometimes on outliers. So our median, we had so many 3s that it stayed at 3. I think it actually shifted to one of the other 3s, but it stayed there. It could have shifted a decimal. It could have gone to like 3.5 and I would have been fine. But the median is a resistant measure. It is really good for when we have outliers, which we kind of talked about that with shape already. When I have an outlier, the median doesn't really get pulled to the outlier. The mean, on the other hand, does. So we looked at that already with the graphs, but this is kind of statistically showing you with some numbers. And then I actually was saying it wrong at the beginning. Non-resistant, the standard deviation, then think about, you had to do 30 minus the average and then divide that. That 30 is really going to take that standard deviation out and the range. And so we're going to talk about it here after this lesson. The IQR is a resistant measure of spread. So basically what that means is I want to use these resistant measures on skewed data because those are the ones with those kind of outliers. They're a little bit farther out. And I can use non-resistant measures because they're a little bit easier to find. I can use those on more symmetric data. Ran out of room. Symmetric. So if I was to describe the graph, I would say it has a skew, whatever, skew left or right with a median of this, an IQR of this, and it has one outlier at blank, whatever. Okay, so resistant and non-resistant measure, those do come up a lot. So knowing which ones really get pulled and which ones don't get pulled as much by some numbers. Okay, feeling okay? I realized on Friday that we just like didn't do the check your understanding on the last page. It worked out, but I was like, oh, I just didn't do it. So, oh well. Okay, so the big idea, I guess, I kind of wrote them mostly throughout. You know, mean and median. So like the resistant and non-resistant. If you didn't have a lot of room there to write that, I would rewrite those here. If you feel good about it, you don't necessarily have to. All of these results are all of these notes are yours. So I don't really care what they look like anyway. So let's see. Resistant, if I write it again. Median. And then I guess if I put, because if y'all look back at these, it might be nice to immediately see, like resistant just means little effect. Would it be affect or effect? I'm always bad at that. It's probably effect. Oh well, effect. Little effect from outlier. So those are less affected. And then non-resistant would be a big effect from outlier. Okay. Standard. My writing on the smartboard has become a little better in year 5. I mean, it's still, that's just my sloppy handwriting now, but it actually looks like what I write. At first, it was just, did not know how to write on these boards. So standard deviation, they have kind of a fill in the blank, sometimes they use, so maybe I'll just write what I have here. So the blank, and I'll fill in here. So the blank would be the context. So in this case, it would be pets, the class average of pets. So you can just put whatever the context of your problem is. So the blank typically varies by blank, which would be where you put your standard deviation, from the mean of blank, which is where you put your X bar. So if I use that on our own problem, it would be the class pets average typically varies by 1.57 from the mean of 2.6, whatever mean was. Something like that. You don't have to write it exactly like that, but that's just a nice, safe way of saying, you know, we're our average distance from the mean. Okay. All right, I want y'all to look at, I already did standard deviation on it. I'm just looking at my other notes that I have. We did that on Friday. Okay, I want y'all to look at the check your understanding. And it just gives you some raw data. It gives you a graph. It wants you to calculate the mean and the median. And then on number 3, what would you use to summarize and explain which one? You can calculate it by hand, You can feel free to type these into Statlet if you want. They also give you that information nice and quickly. Either way.
Since it's 0 to 5, should we do it as like 5 or
Which one?
for like the weight? Oh,
Wait,
oh, I see it now. Just
okay,
kidding. Yeah.
okay.
I didn't see that they actually gave like the individual weights. I just thought they had the graph.
Oh, I
and
see what
was
you're
like,
saying.
it's 0 to
Yeah,
5.
up
what do
above
I
they
count
gave
it
you
as?
the actual numbers, 3.6, 4.0, 9.6. So let's just take a few minutes here and practice getting those. let's see. So hopefully for your mean, just using a calculator for the most part, it's just a matter of plugging them in correctly or into Stafflet. But you should have gotten something like 9.935 pounds, about 9.9 pounds, 9.935. The median is like 6.6. So put them all in order from least to greatest and scratch off the one until the middle, right in the middle. And then number 3, would you use mean or median to summarize, and why? It needs to be, it can be as simple as this, like, I would use median because data is skewed right. And then you're good. That's it. Doesn't have to be too big, too wordy, too much fluff. You just, why are you going to use it? Because that. I mean, you could say something like the median's more resistant. That would be a good term to use as well. Something relating to because the graph is the way that it is. Okay, and then I just put it in Stafflet because I wanted to look at standard deviation as well. So standard deviation is 8.009. So standard deviation is roughly 8. So that just means the mean weight of the pumpkins typically varies 8 pounds from the mean of 9.9 pounds. That's like exactly what I could write for an interpretation. So the average weight of the pumpkins typically varies 8 pounds from our average of 9.9. Okay. So standard deviation just kind of goes off our mean, and then it is saying how wide do I have to make an interval to make a typical range of where we capture our data. All right. Feeling okay? Got some questions? Anything? Worries, doubts, and fears? Okay. I'm going to stop the recording. Right, Alethea? Except, do I know how to? Is the video already gone? Did I record it in the first place? Let's hope so. Is it still going? I don't know.